square and cubes. Level 1. Square and a number multiplied by itself is called the square of the number. For example, 3 squared is 3 multiplied by 3. It is written in index notation. The following are the squares. It is important to memorize them. As a result, you guys will have to memorize them. Now you know what squares are. The reverse operation of squaring is square root. Square root is also called under root. The under root or square root is denoted by the following symbols. Now let's move towards the method to find the square root of 36. First, a table is drawn as shown. Now the number 36 is listed as shown. Now we have to divide the number 36 by the smallest possible prime number. In this case it is 2. Now we have 18 left. The same step is repeated. It is again divisible by 2. Now we are left with 9. The number 9 is divisible by 3. As a result, 3 is left. Then the number 3 is again divided by 3, and here it ends. In order to find the square root, we will have to make pairs of 2. Here in this question 2 pairs are made. One is of 2 while the other one is of 3. In the very end they both are multiplied and we get the square root, that is 6. Solved example. Let's find the square root of 81. First of all, the table is drawn and the number 81 is listed, which is divisible by 3. As a result, 27 is left, which is again divided by 3. Then we are left with 9. 9 is again divisible by 3, so we are left with 3. Then the number 3 is again divisible by 3, and here it ends. In order to find the square root, we will have to make pairs of 2. Here in this question 2 pairs are made. Both the pairs are of 3. In the very end they both are multiplied and we get the square root, that is 9. Cube and cube root. A number multiplied 2 times by itself is called the cube of the number. For example, 3 cubed is 3 multiplied by 3 multiplied by 3. The following are the cubes. It is important to memorize them. As a result, you guys will have to learn them by heart. Now let's move towards the method to find the cube root of 27. First, a table is drawn as shown. Now the number 27 is listed as shown. Now we have to divide the number 27 by the smallest possible prime number. In this case it is 3. Now we have 9 left. The same step is repeated. It is again divisible by 3. Now we are left with 3. The number 3 is again divided by 3, and here it ends. In order to find the cube root, we will have to make pairs of 3. Here in this question 1 pair is made, which is of 3. As there is no other pair, we don't need to multiply. As a result, the cube root is 3. Solved example. Let's find the cube root of 64. First of all, the table is drawn and the number 64 is listed, which is divisible by 2. As a result, 32 is left, which is again divided by 2. Then we are left with 16. 16 is again divisible by 2, so we are left with 8. Then the number 8 is divisible by 2. Then we are left with 4. 4 is again divisible by 2, then we will again divide the remaining 2 from 2, and here it ends. In order to find the cube root, we will have to make pairs of 3. Here in this question 2 pairs are made. Both the pairs are of 2. In the very end they both are multiplied and we get the cube root, that is 4.
Look at the number on the board. We know that 5 is the base and 2 is the exponent. Hence, this equals 5 times 5. We also know that this is read as 5 raised to 2. This raised to 2 can be replaced with the word squared. We know that this equals 25. So instead of saying 5 raised to 2 equals 25, we can say that 5 squared equals 25. We just replaced these 3 words with 1. Why did we give it a special name? Well, mainly because it has many applications. We will see a few in the next video. For now, let's learn something very interesting about squares. What will 6 squared be equal to? Yes, it'll be 6 times 6, which equals 36. Now let's try to find the squares of a couple of negative numbers. Say minus 3 the whole squared. That will equal minus 3 multiplied by minus 3. That equals 9. What about minus 7 the whole squared? Remember, the whole thing is squared, not just 7. That will equal minus 7 multiplied by minus 7, which equals 49. Look at all the answers on the board. They're all positive. What does that tell us? It tells us that the square of any number is always
Hi, welcome to MathAntics. In our last video, called Intro to Exponents, we learned that exponents, also called indices, are a special type of math operation. In this video, we're going to expand on what we know about exponents by learning about their inverse operations, which are called roots. That's kind of a strange name for a math operation, but it will make more sense in just a minute. First, let's review what we mean by inverse operations. In the video called What is Arithmetic?, we learned that inverse operations are pairs of math operations that undo each other. For example, you can undo addition by doing subtraction. So addition and subtraction are inverse operations. Likewise, you can undo multiplication by doing division. So multiplication and division are inverse operations. As I mentioned, exponents have inverse operations also. There are operations that can undo them, and those operations are called roots. To see how roots and exponents work together to undo each other, let's look at the simple exponent 4 to the second power, or 4 squared. Previously, we learned that this is the same as 4 times 4, which equals 16. Doing this exponent meant going from 4 squared to 16. So now if we want to undo that with the root operation, that involves starting out with 16 and then somehow getting back to the 4, which is being raised to the second power. And do you remember what that part of the original exponent is called? Yep, it's called the base. So doing a root operation is going to give us the base as our answer. And that helps us understand its name a little better. The words base and root have a similar meaning, especially if you think of a tree. The root is at the base of a tree. And that can help you remember how root operations work. With a root operation, you start with the answer of an exponent and try to figure out what the base of that original exponent is. Okay, but how do we actually do that? How do we use a root operation to go backwards and figure out the base of the original exponent? Well, for starters, we need to know about a special math symbol that looks like this. And you guessed it, it's called the root sign.